using beyond network, to enhance, the way that people use the technology. So we talked about Ansible, we talked about IoT, we talked about, programming languages. So these sessions talk about this stuff. So I'll try to cover some of this stuff as I go. If you want to take notes about these keywords, you can, search the internet later on. Some of the technologies, I'll try to explain what they are very quickly because we don't have enough time. But I hope you guys are going to get to the gentleman over there from these 60 minutes, 90 minutes, an understanding of the overarching new architecture that we are looking at in the network space. Right? Maybe that becomes more useful than just talking about service assurance. And I always start talking about, what is service assurance? So if you have a network, and most of the guys here probably designed or operated these networks, what's the difference between the network guy and the operations guy, right? The developer or the OSS person, people who manages the network on the day-to-day, right? The network guy will create a network the way that's supposed to be, more efficient, all the routing protocols, all the technologies. But to be honest, the network needs to be managed. So if you build a network that, nobody can properly manage, then on the long run, that network will become a problem. So large networks, large service providers, now, they are not looking at engineering anymore to build that. They are looking at the operational guys and asking them, how do you want to manage that network? And then they will build the network considering those inputs, which is interesting. It's kind of the power of designing a network is moving to the operations. And why is that? Because the operational guy, if they're not able to tell exactly where the problem, in a specific customer experience or how to fix the problem very quickly, there's no point, right? So the network can only be managed if you can see what's going on the network. So many times we rely on, 30-year-old applications like WhatsApp. Who knows WhatsApp? WhatsApp Gold. I used to use that in 1996 when I was managing a couple of servers and a paging system infrastructure. Some people still use WhatsApp, right? And they ping servers and, when everything is green, good. When something is red, no, something is not good, right? And then these tools evolved, but they are outdated. If you know Netco, if you know HP OpenView or Cisco Works, these tools are, used to monitor networks, from the, 30 years ago. They are not working anymore. If you're going to work for a company that is implementing NFV or SDN, that is looking for programmability in the network, you're not going to be able to manage that with the same tools. So that's why we created this session, to talk about how we find the information that inside of that network and use that information. And that ties into you guys, the CNAs, right? When you configure a network, when you configure a device, that device has to tell someone what's going on. So it lies on you, the responsibility to make sure that the network is providing the smarts to operations to manage the network. So I'll skip some of the slides because we don't have enough time, but mostly I want to tell you that the network is as good as you can see. A network that doesn't give you visibility is not a good network, right? So when we introduce programmability, JavaScript, Python, Ruby, we introduce NFV, virtualization, right? vCenter, OpenStack. How can you see through all these logs and understand what's going on, right? So we need tools that can actually understand what's coming from the different parts of the network. And when I talk about network today, I'm not talking about someone sitting on CLI and configuring it. How many of you use CLI on a daily basis? Or as an engineer, you would do it, right, if you were managing a network. CLI is gone, right? I'm sorry to tell you, if you're working on CLI, your job is probably going to be dead in a year, right? So networks are not going to be manually managed anymore. Nobody wants to sit in front of a computer and program, CLI, because that's becoming, something that a robot can do, right? If robots can do, you're not going to be doing it. So we have to move up on the stack to be able to work more strategically on how we manage networks. We need to understand what's the best design for the networks, how they work better, and not concentrated on copying and pasting templates into CLI. because these things are going to go away. So what's happening now is that companies, most of them are still on the stage one of this evolution. They still have CLI, they hire people to go and sit in front of a computer and configure VLANs and configure things. And that's what, it's been happening so far. It's still what most companies do. But now you see companies going to what we call a semi-automated now. They don't want to do everything automatically. They probably have some program, some sort of, utility that can help build those CLIs. So someone that doesn't have a CNA or any certification, just copy and paste templates, right? Pick a template, change some variables, and you can configure a VLAN without knowing it. And that goes on, and then you have automation when, we talked about Ansible. It's a nice open source that can do that. You guys heard of NSO? Who heard of Cisco NSO, ALS? That's one of the greatest tools created so far because it can automatically configure a network for someone who doesn't know network like me. So I can configure an entire network using NSO without knowing a CLI command. So these companies are going to automation. So if I'm a person trying to get into the network market, what I would try to learn is how do I automate the configuration of the network? Not much on how I configure a network. Of course, that's important, but how can I automate that configuration? And that's where, all these jobs come into place. So if I'm hiring someone to configure a network, I don't want someone typing CLI commands. I want someone that can, understanding which commands go into the CLI can build a script so that when I run that script, I can program a network more easily. And my team is now working on what we call self-healing. Self-healing means if a network goes, badly, the systems will have the capability to automatically fix it. So that looks like a dream, but we are already implementing that in some service providers. And why service providers, telecom service providers? Because they have large networks. If you have a problem in a large network, like something simple like a BGP flapping or OSPF spanning tree, that might take a lot of time for operators to figure out where the problem is. And I can put scripts that can figure out in a jiff, right, and fix the problem automatically, or help me fix it automatically. So that's where we are headed, right? You want to have networks that can, be smarter, that can program themselves. Imagine IoT, right? You have a network that has 1 billion of devices. Every refrigerator, every, shoes has an IP address, and you can talk to them, or they're going to talk to you, right? The shoes are going to tell you when, it's getting, the glue is not there anymore, so the shoe is going to tell you, right? I'm having trouble. You better, replace the shoes. And of course, the shoes are going to tell a store when you're walking in. I don't know. How you manage networks with those billions of devices has to be automated, right? So we look at what customers are looking for. So if I manage a large network or a meeting network, I'm trying to cut costs, right? That's where I say, we have to be smarter and avoid, being a person that can configure a network to someone that can understand that, we have to cut costs. And that's true, applying analytics, applying automation into those networks. Networks need to be 24/7. Everyone wants to have Facebook experience, right? I want to access that 24/7, every day, every night, and I can't have a second of interruption. So how we get that? My team view is that you can only get it with analytics, right? I mean, understand the data that is in the network, and I use that to help me solve my problem. So we've been telling people that data is the new oil. So if you are, probably older than us here in Texas, and you have a soil with a good, oil, if you don't know how to export that oil, that's going to be sitting there, and you're going to be losing the opportunity to make a huge amount of money. But if you know how to extract that oil and, process it and sell it gas or, whatever, then you have a value, right? So the network has a bunch of data. How many of you have tried to go into Facebook and then you get an offer from Amazon, about something that you were about to think about buying, right?
That never happens.
Never happens. How do they know it, right? If they just look at your, whatever information you have on your cookie, is the simplest way. But if you look at the networks, if someone can sniff into your network, they know everything about you, right? So how can we get this data from the network and make money out of it, right? That comes the network data analytics, this concept that we have. And if data is the new oil, you have to make that, that data be, worth it, right? So two terms that I always use and people confuse a lot. How many of you have heard of telemetry? I don't actually present usually on telemetry, but I brought a slide on telemetry. So I would ask you guys, do you want me to go deep into telemetry?
No.
No.
No. I mean, just a little bit?
No.
Verbally.
Because I'm not the telemetry guy. I know telemetry is like, in that sense, again, telemetry, for my purpose, is the replacement for SNMP. So SNMP is a protocol, again, used for 30 years. That has done a lot of work for us in the management space. Telemetry is trying to, make it more 21st century. Analytics is the other terminology that we use a lot. And basically, analytics is take a database, with a lot of information and, extract the value out of that. So that's analytics. So if everyone knows about model-driven telemetry, I'll skip presentation on telemetry. So basically, what's driving this, right? So most of the networks today are not NFV-enabled, SDN-enabled, but these are the three drivers for, analytics and big data in the network. It's IoT, SPN, and NFV. So when we got into NFV and SDN, networks are going to have another level of complexity. So vCenter is a good virtualization tool with very stable. OpenStack is not. Most NFV projects are based on OpenStack. So guess what? When something bad happens with the virtual switch or the virtual router, who can tell if the problem sits with OpenStack, with the servers, with the virtual network functions, or with the stitching between them? Nobody can. So you're going to have to find tools that can understand and correlate all this information and provide you with the value, especially with the introduction of IoT. So when we talk about network data, right, what is network data? For us, for network engineers, is basically, the engineering architecture part. So stats from interfaces, how many users are, on a wireless access point. That information is obvious. Any tool in the market can give you that, right? Probably. It can tell you how much, bandwidth is being used, how many users you have, but, can that information help marketing teams or operation teams or HR, or, if you are a Facebook, right? Can this data provide you with insights on, what customers want to buy? No, right? So basically, multiple teams can use that data that is in the network. You want that data, you're not sharing with them, right? So the introduction of analytics not only helps us manage the network, it creates a whole, bunch of use cases for the rest of the business. And then comes the concept of a shared data lake. So in the past, each tool would have their own database. So Prime Infrastructure has a database, HP OpenView, Remedy, ServiceNow. Each one of them are very good at what they do, and they have their own data. And usually, they interchange some things. Eventually, it can integrate. But the data is not, correlated. It's not, put in a concise way in a single place. So what big data offers us is a shared data lake. It's a place where I can dump all the type of information that I have, and then correlate them, make, cross correlations and use analytics to understand models that can predict. For example, if I have data from a weather station, I can correlate that with my network and point where, the network is going to face an outage because of a tornado. I don't know, as an example, right? If you don't have a shared data lake, a place where all that data can be correlated, that's almost impossible, so nobody tries to achieve that. So data lakes are usually, big data clusters or a bunch of computers with a, a significant amount of storage, and you can put that information on statistics, inventory, quality of experience, billing, right? You can eventually give VIP users a better, quality of experience beyond QoS, right? If there is an outage, you're going to fix first the equipment that is serving a specific group of users, for example. So all these things can be done as like examples of use cases when you have this data, shared data lake. And big data is about not only storing all that amount of data, but applying smarts to identify that data. As an example, big data scientist, right? A data scientist probably makes $500,000 per year, just because they know mathematics and they know a little bit of IT, and they can apply a model into a bunch of data and extract value. So if they look at a bunch of syslog entries and they use models, they can eventually understand patterns. So every time that something happens, there's an outage in the network. And then the thing happened again in a certain level, an outage in the network. So data scientists can apply, models into that data and see those things that we can't see, right? So imagine how cool it would be to predict an outage before that happens. How cool it would be to understand, the patterns of a network going down before it actually goes down. You can go and fix it, right? So that's what big data and data scientists is so important. The architecture of big data is usually you need to have collectors, and that's where telemetry comes in, right? I need to have you guys from the networking side sending all the information that I need to these big data repositories, right? So for a network engineer, going forward, to help satisfy those business cases, you need to know where the network data is, how to capture that, and how to push into this big data lake. Once that data is in the data lake, then you're going to have people, running analytics, and again, getting the expertise of the network engineers to understand that data. I can put a lot of events and alerts into a database, but I need someone to tell me what they mean, right? What messages mean, right? What type of correlations you can make? How can you tie topology with an event and make the proper correlation? So the work of a network engineer goes that beyond just writing CLI, but eventually helping identify those patterns of the network, those events, alerts, thresholds, everything that is meaningful, and understand that, tell a data scientist how to make use of that data, right? Data scientists don't understand networking, programmers don't understand networking, but then you have a very good opportunity to help the business.
So you're saying that the real Oompa Loompa is the network engineer who can program but also understands data science.
Oh, that's going to be that person is worth a lot of money.
Now, of course, for example, data scientists don't need to know programming languages, because guess what? Someone already created tools that can just point to a database and put your models, and that tool will, tell you what you need to do. You don't even need to program to be a data scientist. As a network engineer, though, if you want to get into programmability, you need to know network programming, right? I have Samit here that is one of the experts on network programmability that can confirm that. But eventually, some tools as we go, of course, you don't need to know hard code programming to be that Oompa Loompa. You might understand, one or two languages that are essential and that will help you to program a network.
Data scientist necessarily like a PhD in mathematics, or can a regular person have a path to something like that?
I think if you look at job descriptions, they're going to ask you for maybe not PhD, but graduation in mathematics. But I have colleagues in my team that are not graduated in mathematics, and you know what they do? They go on the internet, they Google model for pattern detection. And then you can download that code, put in your tool, and that's it.
I mean, to give a realistic answer to that question, yes, the big guys who are hired as the data scientists, they are masters or above level in data science. However, those guys are they're still super rare. They're super hard to find. You might have one unless you're Amazon, and then you have like 200. So there's still a lot of people who are beneath that who, I'm not a data scientist, but I understand. I can read a data model.
I can still play in that environment.
Yes, and that's what I've been doing. And there are a lot of people within networking who are starting to understand. This is what I need to do. I need to understand either how to read a data model or how to build a data model. I might not need to be able to do both, but I have to do one.
So, of course, the $500,000 salary is for the PhD from Harvard that understand mathematics like those crazy characters from those movies.
Yeah, Elon Musk, those type of
Yes.
But of course, if you're gonna build a solution, right, or like play with the tools, the open source tools in the market, if you're able to understand models and capture those from the internet, from Google, from those guys, you can play with them, and you're not gonna be a data science per se, but
you can't put that on your resume.
Yeah.
You can write it as a project you did, right? But there's a lot of good tools out there that are not necessarily master's programs that can teach you this. So
Correct.
Khan Academy, Coursera. There's a lot of free classes out there where you can go and learn.
MIT classes are free.
MIT.
Yeah, I'll mention some of the technologies that we use that are open source and get you into this, big data analytics. And of course, it's like a curve, right? You're gonna start, like any career, you could start being a person experiencing the collection, part, understanding how to get the data from the network, and there are things like ingestion tools that allow you to push those logs into big data platforms. Then you have all the analytics part, which is, like we said, taking the models and applying the models into the data. And you have another set of people that will be working on visualization and reporting. So how do I get data and display in a more effective way, or how I use tools that have analytics capabilities to give me trend analysis. So it's not a, zero or, data scientist. There is a whole career on that side. And like we said, if we have network engineers that know, those things, it's one of those oompa-loompas that, people are interested. And there are a bunch of slides. I'm going to just keep through, like this one that shows everything that goes into big data analytics.
Can I take a look?
Yeah. And it goes from, the data ingestion, and there are a lot of things like logs, events, logs, things that it can extract from the network, XML files, data from different sources. And then you can run a lot of things on that data, right? You can run processing of the data. You can do machine learning, which is basically have a computer understanding the data and creating a program out of that data. The opposite process of creating a program. And then you have all sorts of open source that I'm going to mention in another slide a little bit, like Hadoop and Spark, all those big data platforms that are open source. And then you have dashboards, you have, all the type of visualization tools. And there's one thing that goes beyond big data that I'm working on, which is the automation, right? So when you automate, or when you identify something wrong with the network here, can you just go and fix it? Do you need to call someone to go and do, that closed loop? So we have tools in the market now that can do that too. So big data started from open source, supposedly free. You can install big data on your company, on your laptop, if you want to play with it, on your, desktop, for free, just by downloading the different components and, hooking them together. So you have a component that does the database Hadoop from Apache Foundation. You have a Logstash that helps you move syslogs into, the platform. So all these things are free. You can actually download them and start playing right now and create your own lab, right? Some of them use OpenStack, because they use containers or virtual machines. But, it's too hard for a company, for, you, for example, to install all these open source and do yourself. So we created a platform called Panda, PNDA, and there's a website called pnda.io. This product can actually be downloaded from the GitHub. By the way, if you don't have a GitHub account, it's time to create one. Right? Some people don't even know what it is. I got a shirt, because Cisco is now a GitHub corporate customer, and the shirt has a space on the back for you to put your username. Imagine you walking, on the street with your GitHub username.
Where do I get one?
So
you didn't bring something to give away?
I think you have to attend one of those GitHub enablement sessions. So you go to GitHub through the panda.io website, and you can actually download Panda. And Panda is a complete package for big data analytics for network use cases. When you install Panda, you get everything you need. You get a Cloudera server, which is the big data. You get all the applications you need, all the components. And this is so interesting that we just got two service providers, large service providers that are implementing this platform with Cisco. And after you deploy this platform, then you can, connect all the data sources, SNMPs, pullers, pushers, logs, all sort of stuff. And then we put applications on top of that Panda, so that you can eventually set up a whole big data analytics within a month. Right? It becomes very easy, very simple. This runs on AWS, Amazon. If you don't have a computer, you want to play with it, or runs on your, a little server you have available, and it's a very cool way of exploring big data.
Can you define a little?
The UCSB series that you have at your house.
Okay.
Oh, they say you can actually install on your laptop because, of course, big data requires a lot of memory and CPU. But if you install on your laptop, the only thing is that you cannot, push 10,000 alerts per second, right? You're gonna be able to play with a small amount of data. But to understand, to learn these technologies, you can install it on Amazon or on your PC with, 32 gigabytes of RAM. And you could probably play with it and learn about it. And what Panda gives you is a wrapper. So you get a console, which tells you which components are working, which ones are not working. When Panda installs, automatically connects all those open sources. They're so complicated to install and configure. Because like OpenStack, those components are made by different companies, right? So Panda gives you a single point of, place for you to control everything and to access all the components. So my opinion is that makes it easier for you to learn. If you had to, if I tell you go to Kafka and create a topic, you're probably gonna click on the Kafka thing and you're gonna see a new topic, right? So going to that screen makes all this complication a lot easier. And by the way, Panda is a open source from Cisco. There's another one called Telemetry. Sorry, it's called Pipeline, that basically can read data from telemetry, from Cisco iOS XR, and ingest those telemetry information directly into Panda. It's another tool that can be downloaded from the GitHub, and it's specifically for iOS XR telemetry type of device. Now, I'm going to just talk quickly about some of the components of Panda so you know what big data is all about. If you install Panda or not, you get all these components. So it's a key component of Panda, but it's a key component of the big data as an industry. So Kafka is a very interesting solution that it's used to transport a huge amount of data at a very high performance in a very scalable way. So think of a postman, a message broker that can take messages from different parties and transfer them very quickly to other parties. And that can escalate from 1 message per second to 1 billion messages per second. And that also offers all the capabilities of reliability. So messages don't get lost, messages can be retrieved, again, so it's a very good way of transporting, in this case, logs.
Does it tie in with Mesos? Does the Kafka tie in with Mesos?
Oh, sorry.
Does Kafka tie in with Apache Mesos?
Does Kafka tie in with Apache Mesos?
I'm not quite sure.
It's like an orchestration.
Apache is so important in the industry that it usually attaches to everything. So there's a tool that we use, for example, called StreamSets, has an adapter for Kafka. Pipeline has an adapter for Kafka. So I'm assuming that every tool that needs to connect to message buses are compatible with Kafka. It's a very established standard.
Apache open source, right?
Yeah.
Yeah. So if it's not working with Mesos, my imagination is, if you put it out there, that it should, at some point somebody will write it.
Because Kafka is like the de facto message bus in the new world.
So what makes it so reliable?
Well, Kafka, the way it works, it creates clusters and partitions. So let's say you have 3 servers. Those 3 servers are going to have Kafka components. When message comes in, it gets saved automatically in those 3 servers.
It's a RAID, kind of.
It's a cluster, yeah. So you can have 25 nodes of Kafka, each one with terabytes of disk. Messages will be distributed across those cluster nodes, and they're going to be dispatched as well to other entities very quickly. So it's based on the number of nodes that you have. You can scale unlimitedly, and basically has all the controls to avoid messages being lost and so forth. So Kafka is a very interesting tool. It's super simple. Can be installed with one command line on Linux. Can be downloaded from the internet, and it's running in minutes. The only big configuration you do in Kafka is create a topic, which is a subject. And the topic could be firewall alerts, another topic could be network traps, So basically, you classify the type of message by topics, and then the messages are ingested in Kafka, and then they are passed across, to whatever we need it to be. So that's the first component of the big data, right? After the ingestion, right? Like telemetry, and the telemetry case, you have pipeline. Now, once the information goes into Kafka, Kafka takes that information and usually passes into a database, right? So most statistical information from the network will go from Kafka directly into what we call the HBase, which is one of the components of Hadoop. And then once it's stored on that, big reliable database, it can be used by other tools to, manage that data, display that data. So Kafka is the most important tool. It's responsible for the, transporting of the message. The Hadoop cluster is the storage of the message, is the second most important one. And then the third most important one, especially for users, is the way that they see the data on screen. And I laugh about it because, it's not supposed to be like that anymore. The way big data goes, I should not have someone looking at a screen like that, trying to find an anomaly, right? On the internet visualization, I should not have something like that. I should have mechanisms where when an anomaly is detected, something automatically goes and fixes it. So, the only reason to have this thing is to sell a product to a customer. They're gonna look, oh, fancy, right? Does it have dashboard? Right. Because, looking at screens, it's important, yeah, but it's not gonna be as important as, it used to be in the past. So before the data gets into this portal, you're gonna run analytics to find anomalies. So every time there's a pick, some programs, oh, look, there's a pick here, right? I either have to notify someone, create a ticketing remedy, or I have to go and do some automated testing, try to find the problem and fix it. So I don't really need, a bunch of dashboards anymore. Maybe just for, the NOC, right, or the place where you have those big monitors. So Grafana comes with those open source components, and Grafana allows you to quickly create any dashboard based on this time series information that comes from the network. Interface counter, BGP routes, memory, CPU, whatever comes, Grafana is one of the tools that can show to you. And this tool is free again. So I remember when these tools were, $1 million license.
Yeah.
Grafana is JavaScript based, right?
Yeah.
Okay, thanks.
Well, there's Grafana, but there are other tools like Prometheus. It's another, type of big data platform, and some of the Smart that I'm showing you, like another alternative, and can work with Grafana. Grafana can work with InfluxDB. So these tools are, you can actually pick and choose a variety of combinations, and they will give you the same outcome. Panda gives you a proven set of applications that are already validated to work together. So Grafana, Kafka, Apache Hadoop, these are the core tools that one will need to learn to get into this world of big data analytics. They are not complicated, but again, need some software skills, right? Some understanding of configuration of software and things like that. Now, why big data is important? So, I'm very actually upset because people don't know what ITSM and OSS are anymore, apparently. We had a session in Cisco, and the title was OSS, Open Source Support. That's not open. So OSS for SPs and large ITs, operating support systems, all those systems that you have to keep running to maintain your network, right? So if you have a network, you have ITSM or OSS tools on top. So in the past, OSS tools were siloed, like we said, right? So what big data does, it kills all the silos. So all the data from different, network, compute, storage, whatever, they go to the same data lake, and those OSS applications can drink from that data lake. So you remove all the silos, which is obviously a good thing. Well, now we talk about big data, right? So first step, for a company, you have to implement big data platform. Panda can help you with that. Second, we have to identify data sources. That's where you guys come in, network guys. Where the network data is located, how can be better consumed. Is telemetry better than SNMP? Can I find more MIBs, right? How can I suck all that data from the network and and make available for others to use. Then ingest. What is ingest? It's taking that data and finding the best way to put into the big data platform. Are you gonna push data every second, every minute? Are you gonna aggregate the data? Are you gonna push all the logs? How are you gonna do that, right? Is that files, REST calls, syslog calls? How are you gonna ingest that data into the platform? Then transform. Because of course, if you get logs from Cisco and Palo Alto, they might have a different format. So you might want to normalize that, right? Host, message, timestamp. So you do a lot of normalization. Then you put in a database, in a big data database. So the data is stored, and you're gonna have to do, calculation, how much data you want to store for how long. What happens next, right? So now how we define, the next generation service assurance, how you use that data. So we have this concept of, self-healing building block. So if your goal is to have a self-healing network, how do you get there? So, of course, we know the infrastructure side. We have that. We introduced one layer called distributed collection and transformation, which is basically this big data storage. And once we have all this data installed in this data platform, we can run use case on top. So the most important use case is from network. I think you guys agree with me. That'll be performance, how the network is behaving, capacity, because if I don't have enough capacity, at some point performance will be degraded, and fault. Something happens bad with the network, right? How you fix that. So what we are doing is on top of fault, and by the way, we have a solution for fault analysis that comes from a partner that implements machine learning and all the smarts that I'm talking about. So we are implementing that self-healing closed loop action using NSO, Cisco NSO, that goes and automatically fixes the network. So I actually have a demo if you have time to run it. Basically what it does is it detects an alert from the network, for example, a shutdown interface, just for fun. And then it sends a lot of alerts, there's a BGP error, 2 interfaces error from both sides, and some other errors that, configure IPSLA, stuff like that. And these tools can automatically have a good slide.
But if the source is a daily log, your automation will be rather slow.
Sorry?
If your source is a log daily,
Yeah.
your automation is going to be rather slow.
Yeah, good point. Actually, this platform, and this was on my other telemetry presentation that I didn't use, but the mean of big data is to be real time. So big data expects things to come in real time and get out in real time. So logs, for example, you're going to use syslogs to send logs as they go. You're probably not going to load logs every night. You're going to send them as they come.
Well, that brings up another item of a daily log is going to be just compiled over the course of the day. So you're not going to have. You're not going to have the data being just released instantly.
No, you get SNMP traps, you get logs instantly.
Yeah, you
Right.
get
Using
the
syslog.
you define the destination.
So that's the use case, of course. If you don't need that log data to be sent every second, every minute, or when they happen, you're going to run a nightly.
Yeah, so you remember your Kafka bus, part of your Kafka bus is you're having your syslog, whether that be syslog NG or some other syslog collector that's getting syslog from your entire network. All of that data is now feeding into your Kafka bus. Your Kafka bus is then ingesting that through different methodologies and instantaneously saying, here's a huge span of messages that says BGP went down, BGP went down, BGP went down, BGP went down. That interface over there went down, which I think was kind of what you were.
Exactly what happened.
Yeah.
So I'm not a network engineer, so it's,
Right.
I like your explanation. So you get those syslogs saying that things are happening in the network, and then you get traps, and then, these tools can automatically eliminate the noise and correlate all of them to tell you exactly at this second there was a interface going down, and it's actually affecting all these other routes and equipment, but it can tell you exactly what the problem is, what the source of that problem, so you can go and fix it.
Right. If you think about like alarm correlation, so if you think about a core network interface, how many services are tied to a core network interface, what would happen if somebody ran into your data center and just went, I'm going to pull these these cables out and just ripped them out, right? All of a sudden, it's not just gonna be like, oh, these 3 ports went red. Your board is gonna light up and it's gonna be red, and everybody's gonna run around with their hair on fire because they got no idea why everything in the NOC just went red. But it really just comes down to go plug the ports back in, so you just want 3 data points, right? Now, I don't think Panda can't go plug the ports back in.
Oh, not in that case, right? Look,
Yes.
ignore all these alerts, go to that router and fix that cable, right?
Right.
Because that now is administrative down.
Right.
But in some cases, when, you do a shut on an interface, you were not supposed to, right? And that breaks things that you're not supposed to do broken, so then the tool can go and bring that port up before you actually realize you did something wrong. So it's very powerful.
It's like the old EEM script that they like to put in the CCIE lab, that whenever you shut down the interface, it would automatically bring the interface back up. So you'd be like, I can't figure out what's wrong. Oh, the interface is back up. Shut it down. Oops, nope, it's back up. It's preventing you from doing the bad thing, assuming that you told it what the bad thing is.
Yeah, so don't get me wrong, this tool, I'm not telling you it's a magic tool, right? It will do everything out of the, because we know it's not happening like that. So this is all based on prerequisites. So we have a solution, like I said, called NSO TLS, which you can compare to Ansible. It makes more sense if you don't want to use a Cisco product. By the way, TLF NSO is multi-vendor. NSO does the provisioning of a service, right? Let's say you have a bunch of users, and it configures VLANs, it configures, things on the network. So NSO knows exactly what is being provisioned on the network. NSO can tell you, look, there's a service configured for
BGP.
for a user, for the service, and in this location, NSO knows exactly what service is behind the CLI, right? So when I go and configure a CLI, I create a VLAN. I don't know if a customer is using that VLAN. I don't know if, there's something that categorizes that VLAN, like a service, like a voice or data. I don't know what it is. I just go and NSO knows everything. So based on this information that NSO knows, NSO pushes the configuration into the network, and at the same time notifies this assurance tool about this service inventory. So it tells assurance system, look, VLAN 101 belongs to Renato. He's running voice on it, and this network is shared with another customer. That's it. So NSO knows that and passes here. Now, when you get an event on the network, and it can be in any place of the network, that alert goes to this assurance system. This system can tell exactly Renato is now with no access to voice system because, that VLAN went down, for example. So it's able to do all the correlation, not magic, right? So that's because assurance knows all of it. It knows exactly what went wrong and which user is affected. It can go back to NSO and say, look, you have to go and fix that VLAN because Renato cannot access the voice system, right? So that's the idea. And it's all based on NSO for the automation part. NSO, it's a very interesting tool because it abstracts everything from everything. So if you have NSO provisioning VLANs on your network today with Juniper, and you decide to buy Cisco, you don't even have to touch the software. You just tell, from now on, it's a Cisco CLI, not a Junos CLI, and NSO will actually help you migrate all your services from Juniper to Cisco. And at the same time, you will not have to teach NSO how to configure the network on the new device. So all the abstraction layers, all the APIs, capabilities, programmability, one person can actually program NSO just by knowing YANG and XML, I think. If you know Java, right, you can actually do real cool programming. But to stand up the provisioning capabilities on NSO, you know YANG, you know XML, just simple languages, you're already doing network programmability. Right? And if you know a little bit more, Perl, Java, Python, then you can do really cool programming. So I think the idea, like I said, is, these tools should be able to understand the resources that are on your network, so you don't have to keep a spreadsheet, the available VLANs IDs and the available IP addresses. That's gone. So these automation tools have those, inventory resource pools. So that is used. NSO has a checking capability, for example. So before NSO goes and attempt to make a change in the network and screw everything, NSO does a simulation. NSO tries that configuration on the, on the internal simulator, and that configuration is okay, then it goes and applies to the network. And if still it doesn't work, it has the capability to roll back. So you are, completely sure that this automation is not going to make it worse, right? It will make it better. And so test everything, then so provisions the service, or in this case could be fixing the service, right? Reprovisioning the service, and then deliver the service, notifies whoever has to be notified, the system or someone, and then notifies assurance, right? Mr. Assurance, now I have a service for Renato on the voice VLAN. And on the other side, when something happens on the network, then all those billions of events and alerts and traps and logs that, start popping up, it's impossible for a person to understand what's going on. Solutions like this one that we have, through a partner, MoveSoft, they have the ability to filter that down, remove the noise, detect what's the situation. Something's happening in the network. I'm going to call it a situation. I'm seeing logs, events, I don't know what's going on. MoveSoft can tell you what the situation is. And then it can act, means that, MoveSoft can call people to troubleshoot a problem using a virtual room, or it could go and automatically diagnose and fix the issue automatically, making a call back to NSO. Or for the sake of, open source could be Ansible.
Question. So whenever you're fixing an issue, it just service redeploy, or you have to create special package for identifying and fixing those?
It depends on the issue. For example, in our use case, we understand that even the large service providers, they don't really want to automate all this fixing because they are always afraid that, something goes wrong, and then the robots start to fixing things, and they might not know what's going on, and, it goes into a loop. So the approach is basically this, right? We use MoveSoft to go into all the devices and extract the information that an operator will be actually going manually and doing. For example, taking the show run, taking the, all the show interface information and putting that into the ticket. So automatically, when an operator goes into the system, they see all the interactions with NSO. Now, the next stage will be NSO telling you what you would do to fix the network, right? NSO, for example, will say, in this case, I would shut down this interface, or I would redeploy that service, or I would take this interface down. And then operators, for a little while, they can confirm if that's what they would have done. And if that's so, they will do it and will fix it. And then on the third stage, then NSO will do automatically. So when you are comfortable that the automation is supposed to do what it's supposed to do, then you let it go. And some of those simple problems can be solved very quickly.
And some of it could just be that you have a human validation step, like you're saying, where if the network is just saying, I'm going to go do this. Are you okay with me doing this? And you're like, yes, that makes sense. Go do that. Because I think what a lot of
finger, right?
Right. Well, what I think a lot of network engineers remember are the early days of EIGRP, where a lot of people were like, oh, we can turn on all these K values. And you turned on all the K values for reliability and all sorts of stuff. And it was like, well, what is your network doing? And the answer was, whatever the network wants to do. I don't know. I don't know what my network is doing, and that's a problem. So there's a lot of people who still remember that. And MPLS traffic engineering, you can have some of that where it's like, oh, well, if this goes down, fast reroute, fast reroute, fast reroute. Okay, everything's fast rerouted everywhere. I have no idea what it's doing, but it's still working, but that's not good enough. I need to know how it's working. So you still have people who are trying to fight that. And so there's still the human intervention process that's happening.
So the good example is the fat finger, right? Someone went to the CLI and was configuring a VLAN and by mistake put another VLAN in place. Now NSO on the first call to a device, first NSO checks if the configuration in NSO database is the same in the device. And in this case of the fat finger, someone screwed up, let me roll back. And we'll automatically fix that configuration on the device so that the problem will be restored. Or, it could be something more complicated like someone pulled a cable and an interface went down, and then NSO wouldn't be able to fix, but at least notify someone that, go there and bring that interface back and the problems will be solved. So, of course, the program doesn't come with all these smarts, right? So NSO is a platform, and you guys, the network guys that can learn Yang and a little bit of XML can configure NSO to do all that smart, right? So that's, again, an opportunity for a network engineer. to getting to, being what I don't like to call a full stack engineer, because that's more, used in software, right? You want a person that can program, test, and release and operate a solution. But on the network side, like I said, we are trying to bring together the programmer and the network person. Now, full mesh is going to be the unicorn, but if you get closer to, being a orchestration network SME, that's where should I?
And I think that's what you're seeing today with a lot of this, is that you see a lot of people who, I understand how the network is supposed to work, and I can write a program that will functionally do something. But I'm not a programmer, and a programmer would have fault handling and error and exceptions and have tests that are very defined on, that they'll understand the process of, here's how I write a program and test it to make sure that when the user does it, it doesn't crash their laptop. I don't have that experience in doing that, so I'm going to write a program, and every once in a while, it's going to do something that I really didn't want it to do. So I think that's where you see the human intervention still happening, is because we're having a group of people over here and a group of people over here who are just now learning how to come together, and we don't trust the other side yet. So.
And that's where it comes to job descriptions. I got a call the other day, we need to hire a DevOps person. How many of you have heard of the DevOps, right? We need a DevOps engineer. What is that, right? So
it's a guy named DevOps.
Maybe that's what it is. I have a colleague, Jason Davis is a distinguished engineer, and he was presenting at Cisco CLI saying, you want to do DevOps, the first wrong thing you do is hire a DevOps engineer. Because DevOps is basically taking a person from a developer and teaching them how to operate, and vice versa, so that person understands, again, right, the unicorn, right? Someone that can build a code, test the code, and, understand how that operates. And at the same time, you don't need that person to be that way, because DevOps is supposed to be a team of people working as one person, right? So the real DevOps is a network person, a computer person, a storage person, a project manager, a operations person, and a security person working in terms of agile, right, in a group for a project, so that they can do things more rapidly instead of going through the traditional gates where I program something on the network, then I pass into the storage guy who will do his thing, and by the time it gets into operations, it's not doing what I had envisaged, right? So DevOps, you don't hire DevOps engineers, you hire people that can work as a DevOps team, right? That's how you do it. And again, it's a buzzword, right? It's someone with DevOps experience. Most funniest word, right?
I should put that on my resume.
You can put it. I know DevOps. I know the networking part of DevOps. So it's basically people that can work in a team together instead of isolate, right? That's what DevOps and Agile are. If you can work with people, you are a DevOps person. And again, just keep the telemetry part. The same way we did that with default, right? When something happens with the network and fails, we can do it with performance. We have a bunch of tools that can suck all that data from the big data and do real-time analysis of performance and tell you right away, look, this link is going to go down because of the amount of users, or there's a DDoS attack, right, that is causing performance degradation in the network. So these performance tools can also go and provision additional virtual machines. They can go and I don't know if it's a VPC, virtual packet core, which I don't like to use an example, but in the mobility world, you have a bunch of subscribers, going through the internet on their mobiles. When that number reaches a threshold, you have to create another virtual machine so that more subscribers can continue navigating through the internet. So those things, performance can automatically fix for you. And that's an example of a real project that we did in Europe, and it's a worldwide network, and NVDA and SDN enabled, which means that someone can go to a portal and say, give me an L2 VPN link between a Starbucks in Frisco and one in Sydney, Australia, and that network will be automatically configured, via programmability. But the cool thing is that for a solution like that, there was no assurance available in the market. So we had to build one. And again, we built using this concept. So again, these concepts have been proven to work really well. So we suck all the data from these devices worldwide, or from one location, doesn't really matter. We consolidate them in a central location, we put on a big data cluster, so all that data is available, and then you can run all sort of use cases. You can run capacity for all these links worldwide. You can know exactly, in real time, which networks got provisioned, because now, guess what? VLANs can be provisioned and they provision on the same day. Network overlays can come up and down in a matter of hours, depending on what people need, right? I need to run a backup overnight. I'm gonna go to a portal and ask for a bandwidth, higher bandwidth overnight, and run the backup and I shut it down. I only pay for that amount of time that I hired that bandwidth. So how you know when something goes wrong or someone is provisioning something or something went wrong? Imagine, those new next generation networks who need that type of thing. So all these things, they are multi-vendor. So I'm a Cisco person, and I like to sell this because this is not a Cisco thing. So all the solutions that we work on big data, because it's open source, because it's supposed to be open, it's multi-vendor. So all the things we do are not only Cisco. They work with Juniper. They work with, whatever other vendor out there. They're community-driven. So if you have some problem with Kafka and you think, oh, somebody should think about that, and if you post on the Kafka, community, someone will also find interesting and they will develop that functionality for you. Not like calling, Cisco or Juniper saying, can you add a feature to this product? And eventually, well, yeah, in 6 months, in 12 months, depending how much people are interested. The community is community-driven, right? Some things can be adopted and modified very quickly. By the way, if you're getting into this world, another thing on software, you may tell people on your resume that you know programming, Python, Ruby, and they're going to ask you, what's your GitHub ID? How many projects have you browsed in the last 3 months? And they can see that on the GitHub statistics, right? So they're going to measure the candidates by seeing how interactive they are with the community, right? So if you are going to the community, you're contributing with manuals, user guides, or with code, or with ideas, you are active in the community, that's, things that are going to shine, are going to be on your favor. So, like, if I get a GitHub account, the recruiters are going to ask, same way they ask for your Facebook and Twitter accounts. And then, if you start collaborating, browsing the code, downloading, then you start to becoming active on this community. So it's very interesting from a, open source, open perspective. And partner focus. So we work with partners. So if you guys work for partners, Logicalis, for example, we have partners in software. We need partners to move this forward because, again, it's not a Cisco thing, right? It's an industry. Big data as a whole, right? Need collaboration from all the different parties. So we're working with partners. And some of the examples, I said MoveSoft is the tool that we use for fault management. It's one of those gold partners from Cisco. We are also investors on that company because it's a really cool one. It's from the same creators of Netco. Netco creators created MoveSoft. Grafana is open source, so we act on the community. And we have a bunch of other vendors like NetRounds is a company that can help you test your network automatically. You basically provision a virtual machine somewhere, and you use a physical box somewhere, and it ingests traffic between these two devices and can tell you if the connectivity is working or not, without you having to go there and start doing ping and so forth. It's called NetRounds. NetRounds. And it works with NSO already. It's on the ecosystem. There are very tools in the market now with programmability, with APIs, that you can stitch them together and create solutions based on the openness of the solution, APIs, and open protocols, and stuff like that. So another interesting thing for these solutions is that, just out of curiosity, they are supported by Cisco now. If you call Cisco and say, I have a problem with Kafka, I use Panda, I'm a paid customer, and I use Kafka, we provide full support on open source, which is cool. And Cisco is not only working with Panda on the open source, it's starting, I'm always very skeptical because I'm a software guy, and I don't see Cisco as a software company, but Cisco is actually very heavily engaged in open source projects. There's not only Panda. By the way, Panda is being used by the MEF, the Metro Internet Foundation, is being used by large customers, by small customers. Some of them didn't even come through Cisco, right? They downloaded Panda and they are using it. So contribution from Cisco. FDIO is the virtualization, improvement on the network. The virtualization of the network device is driven by Cisco. The SDN controller, Open Daylight, and so on. So there are a lot of projects that Cisco is contributing on the open source community, which is interesting. So I talked to you guys about the assurance, and I can show a quick demo. Basically, we take all these configurations of the network that are done on NSO, or Ansible for the sake of open source. By the way, Ansible is very easy, but it doesn't have all those rollback functions and things that NSO has, abstraction, but it's very, very interesting. We are using Ansible in some of these projects. So NSO provisions the network. Network tells Panda, through Panda, when there is an event in the network, Panda can tell the MOOC or, interface with the ticketing system so that events in the network get recorded, get classified, get correlated, and then the cross loop on the top makes NSO smart enough to go and fix the problem. That's the detail, and that's how, if the demo doesn't work, that's a Microsoft screen, and it's very similar to all the traditional tools that are out there, SolarWinds, Netcool, OpenView. Well, the big difference is that you get a situation over here, which is equivalent to a ticket, if you think about Remedy and ServiceNow. On the top, you can see all the events that got linked to a situation. And of course, you can access details of them, like timeline. When did I receive the first event? What was the next one? And then you can analyze and understand the flow of events that led you to that incident. You have another interesting knowledge base, so you can actually see, the tool can compare this to previous events. So I can tell you, last month, we had the same problem, or very similar problem. Why don't you look how that got fixed? What was the problem? And maybe you can, solve that more efficiently. And all the NSO messages I talked about, they appear here in discussion. So discussion is like NSO talking to you, right? Oh, connected to this device. These are the show run conf of that interface. This is the interface tab. It provides you with all the robots, right? People talk a lot about bots, right? And the other one is the performance and capacity management. And basically, it's a tool that we created in AS called Matrix. It's used mostly by service providers, but since it's a platform, it can be used by enterprises. It can be used to do performance for HIP and Wi-Fi network, routing, switching, or any type of network. We basically have an admin interface where you can come and configure the KPI and point to the database inside of the Hadoop or your regular database, and then you can plot that out on screen, and you can generate models, trend analysis. This is a tool built by AS. It's not a Cisco tool that you can find and buy. But we deploy as part of the services organization when we engage with customers.
Buy services.
Yeah, if you buy a solution, this will be one of the components along with partner solutions, open source solutions, and Cisco solutions. The way we approach it is creating solutions, not products. That product.
We create services, not products. We're services, so we create services, not products. That's for the product.
I call solution, but it's hard to define what is a product, what is a solution. So to me, you have boxes of products that you buy out of the shelf, and when like Microsoft Office is a product, you install it, it's running. Now, when you buy NSO, it's a product. Now, when you combine the OpenStack with the big data, then you have a solution that is delivered by services because you have to stitch these things together. So basically, I think the message I had is that, the networks are evolving. The networks are getting, especially on the large networks, the virtualized networks, they're getting complicated. It's being very hard to manage the first NFV networks that are being implemented out there because you can't just, look at a piece of the infrastructure and point your finger where the problem is. Now, things could be because of a programmer that built the wrong code or because of OpenStack. That is misbehaved. The programmer. I just have to point to someone. Basically,
he's throwing me under the bus already.
So my concern is, I'm sure the network guys are going to be able to build very, advanced networks, and they are already doing it. But my concern is who's going to manage that? How they're going to be managed? If we don't, get the same smarts on the network, like the overlays, the programmability, the virtualization, all the funky stuff that we are doing, telemetry will help us, big data will help us, and the new generation of tools that use machine learning, analytics, all these new things are, the solutions used to manage this network. Let me see if I have.
You're absolutely doing good on time. So for those of you who are keeping score on languages, the language that you kind of mentioned the most.
Big data is just a flat table.
Yang, XML, which I don't know that XML is a language.
Regular data is relational tables, right? Like
And the big data actually, think of a file system first. So they have something they call the HDFS, which is a file system that span across multiple servers. So most of the big data clusters, they have 500 servers, 1,000 servers. So the basic is the HDFS, which is a file system that span across, and then you can put things on top. So for example, if you put a CSV file on that file system, you can query that CSV file like a database. You can select from, and you give the name of the CSV file, and you can query that data. Or you can store the data as images and audio and retrieve them. Or, there are different things of accessing the data that goes into the HDFS. And the basic concept is that.
Just the storage part of it.
Yeah, it's a file system that stores that span across all
What about the formatting of the big data?
Oh, the data can be any format. Like I said,
whatever format you can read.
like I said, you can put a CSV file. You can put a binary file inside that is like OpenTSDB, for example. OpenTSDB creates folders on that HDFS, and the files inside of the folder contains those. There are different ways of.
JSON, XML,
very popular.
those JSON, XML, CSV, I think are the most common ones that you're going to run into. Binary, I guess you would run into. I haven't seen anybody do anything with that, but yeah, for those of you who are keeping score, like I said, the languages that we mentioned the most here, for those of you who are going out and saying, I want to pick up another language, or I want to pick up a language, my first one, the ones that we mentioned the most, Python, XML, Yang, JavaScript, kind of where the areas that you might want to manage. What, Steve, you want to share with the class?
JSON, XML, and
Spanish.
I'm gonna work with you.
Sí, es una buena lenguaje.
You could have at least said Italian, man, come on.
Spanish, you can do it.
Tu italiano?
I'm from Brazil, but I understand Spanish.
Wow.
Portuguese, okay.
Yeah.
You said JSON, XML, and what was the third one?
JSON, XML, JavaScript. Yeah, Python is
For the storage file.
Oh, for storage?
Oh, JSON is the format one of the most important formats of the file because JSON uses HTML.
That's
CSV, which is, that's not, hopefully most people in the room know what CSV is.
No.
Excel, right?
Not anymore.
I asked the developer.
Okay.
I asked the developer to create a CSV file, and he created like a timestamp, message path of a file, and he created like this: time, capital letters, colon, and then the time, the actual value, then comma, then the other title of the other field. No, this is not. This is nothing.
Reinvent Excel.
CSV is just values separated.
I was thinking you were going to say, he created like a
No, not even that.
Not even that. He just had unstructured data.
He just didn't know what CSV was. How come someone doesn't know it? I think because XML are more popular now and
XML is huge. XML and JSON.
So I have actually this one recorded, which plays better because I'm not sitting at home. Might not have the credentials. But what it shows basically is that Moog is empty. There's nothing there, and this was good for a VPC type of environment and could work on your network. So the use case is users start using the network, and the IP addresses exhaust. Right. So what happens in general? The next user won't be able to get an IP address, won't have access to the network, and they'll cause a pain until you figure out. Many users are complaining. So what this does is puts traffic on the wire, and a lot of users start to get messages like IP pool exhausted, and what the system does automatically, it goes in and create more IP pools, more IP addresses, so that, users can continue, being provisioned and accessing the network. Like I said, there was an event, and you see here the message coming on the bottom, so it's all automated, right? If I don't pause, don't even see what went wrong. So you got an alert. When you click on the alert, these tools, they apply machine learning so they can classify, the precision of that alert, things like that, what happened before. Now you see the NSO is already talking to the device, and it's bringing all the, the inputs into this operator view. So operator can see what's going on, why, the IPs are gone. It says there are 6 total IP addresses and 0 available. And then NSO continues going on. So it goes and, brings interface information because it doesn't know till now what's causing that, issue with the users not getting IP addresses. Identifies that there are 6 users that actually got an IP address, and after that, it didn't go any further. And what it does, it tells you, executed IP pool, P2, and a range. So it's adding IP addresses to that pool automatically. And then to make sure NSO goes and ask again for that show IP pool, and now shows that you have another 6 available. Right? All of that happens without human intervention. If the user was not looking at this screen, it would go from, red, yellow, green. You wouldn't even know. That's what happened.
That's what happens on all networks, right? It just goes red, yellow, green without human intervention.
Yeah.
And then next day you have a refund my privilege money.
But the beauty thing is that this uses analytics. So eventually, next time it happens, NSO will not waste the time to, query everything. We'll eventually just go and fix it because we'll match with the previous problem, and the solution that worked will apply the same thing. So it's easier, machine learning, it's using advanced analytics, and all of that based on the simple fact that, the data that was already, coming from the network is now being used more intelligently. Hope that makes sense. I went too fast.
No, I think it was good.